In this video, we are going to discuss a problem based on the autoregressive process. Okay, let us start. Find the mean and autocorrelation function. Find the mean and autocorrelation function of a of second order autoregressive process AR of 2 where W of n is white sense noise is a white stationary process. It is a white stationary process, and our AR, that is autoregressive process, is given by x of n equal to minus summation k equals 1 to p x of n minus k into ak plus b naught w of n, where n is greater than equal to 0 and my p is 2 because the order is given to be 2. Here my expectation of w of j into w of k is delta jk of sigma squared. Right, let us now go ahead to obtain the mean and autocorrelation function of this process. So starting with the solution, I have from the problem my x of n is minus a1 x of n minus 1 minus a2 x of n minus 2 plus b naught into w of n for all my n greater than or equal to 1. Now it is assumed that a1 and a2 give a stable causal system. So my assumption, a1 and a2 give a stable causal system. Now clearly I know that the mean e of x of k equal to 0 for all n greater than or equal to 0. Right. Next we need to find the autocorrelation function. So how to find autocorrelation function? Right. We know that the formula for Rxx of n comma n, that is autocorrelation function Rxx of n comma n is minus summation k equals 1 to 2. I will have ak Rxx of n comma n minus k plus b naught squared sigma squared. Similarly, my Rxx of n comma n minus 1 equal to minus summation k equals 1 to 2. I will have ak Rxx of n minus 1 comma n minus k, n minus 1 comma n minus k. How did I get this? This is nothing but when I subtract, I will just have n minus 1 minus of n minus k, giving me k minus 1 over here. Similarly, my Rxx of n comma n minus 2 will be minus summation k equals 1 to 2. I will have ak Rxx of n minus 2 comma n minus k. Now, assuming n to be sufficiently large, we take n to be sufficiently large, taking, and the steady state condition is reached, and Rxx of k equal to Rxx of minus k. This follows because autocorrelation function is an even function. The above three equations may now be written as Rxx of 0 equal to minus a1 Rxx of 1 minus a2 Rxx of 2 plus b naught sigma squared. Similarly, my Rxx of 1 will be equal to minus a1 Rxx of 0 minus a2 Rxx of 1, and Rxx of 2 will be equal to minus a1 Rxx of 1 minus a2 Rxx of 0. These three equations, which upon solving we will get which upon solving we would get Rxx of 0 1 minute, uh, which upon solving we would get Rxx of 0 equal to minus a1 Rxx of 1 minus a2 Rxx of 2 plus b naught square sigma squared. Let me take this as equation number 1. Then let me consider the equation for Rxx of 1. So here my Rxx of 1 is minus a1 Rxx of 0 minus a2 Rxx of 1. So let me write it down here. My Rxx of 1 is minus a1 Rxx of 0 minus a2 Rxx of 1. So from these equations, if I bring Rxx of 1 to one side, I will have Rxx of 1 equal to minus a1 divided by 1 plus a2 into my Rxx of 0. So again rewrite this. I will have my Rxx of 0 is minus of 1 plus a2 by a1 of Rxx of 1. I am going to take this equation as my equation number 2. So considering this equation number 2, let me now move on to my Rxx of 2. My Rxx of 2 equal to minus a1. I had Rxx of 1 minus a2 into Rxx of 0. So this, when I substitute here, I will have minus a1. See, I'm going to substitute for Rxx of 0 in terms of Rxx of 1. So I will have minus a1 minus of minus positive a2 into 1 plus a2 divided by a1, this whole thing into Rxx of 1. So now I have written both Rxx of 0 and also Rxx of 2, everything in terms of Rxx of 1. Let me take this as equation number 3. Using all these equations, in my equation number 1, so using all this equation 2 and 3, in my equation number 1, I will get I will get my Rxx of 1 equal to uh, final result will be for Rxx of 1. However, when I start initially, I will be having my Rxx of 0. This value will be equal to minus a1. The first term in equation number 1 is Rxx of 1 minus I will have an a2 into Rxx of 2. So here I will substitute for a2 from equation 3. I will get minus a1 plus a2 into 1 plus a2 divided by a1 into Rxx of 1 plus I will have the term b naught squared sigma squared. This upon rewriting this upon rewriting and substituting for Rxx of 0 also in terms of Rxx of 1, I will have minus of 1 plus a2 divided by a1 into Rxx of 1. This value will now be equal to, let me take LCM here and combine the two terms. I will have minus of a1 squared minus I will have a1 squared into a2, so this will give me minus a1 squared a2 plus I will have a2 squared plus I will have a2 cube all divided by a1 into Rxx of 1 plus I will have b naught squared sigma squared. Now proceeding with this term, I am writing everything in terms of Rxx of 1. So when I write everything in terms of Rxx of 1, I get my Rxx of 1 by doing some little algebra. I have a1 b naught squared sigma squared divided by I will have minus 1 minus a2 plus a1 squared minus a1 squared a2 plus a2 squared plus a2 cube. This would be the expression that I will be getting for my Rxx of 1. Now use this and substitute in equation number 2 and equation number 3. When I do this, I will get the values for my Rxx of 0 and my Rxx of 2. Okay, this is how we find Rxx of 0, 1 and 2. Now what happens for lags greater than 2? When the time gap is more than 2, then I will have Rxx of n comma n minus j. So this is nothing but minus summation k equal to 1 to 2. I will have ak Rxx of n minus k comma n minus j. Here look at this term, my Rxx of j, because this n and n minus j, when I subtract the time gap is j, I will have this as Rxx of j. So this value will now be equal to minus summation k equal to 1 to 2, I will have ak rxx of j minus k. Let me take this as equation number 4. Now, taking this to be my equation number 4, let me put j equal to 3. If I put j equal to 3, I will get rxx of 3 to be equal to minus a1 rxx of 2 minus a2, I will have rxx of 1. So this equation number 4 now gives me a recursive equation. Formula, and using this recursive equation formula for generating autocorrelation function for or generating the autocorrelation function for all j which is now greater than or equal to p. So now in this particular short video we have seen how to find autocorrelation function for a second order autoregressive process. It has been found for Rxx of 1, 2 and 3, and for values above this, that is when the lag exceeds 2, we find that the autocorrelation function gives a recursive function formula using which the problem gives us a solution. Thank you for listening.